Good morning, my YouTube viewers. In this video, what we're going to be discussing is confidence intervals. Confidence intervals are a fundamental concept in inferential statistics, providing a range of plausible values for an unknown population parameter based on sample data. Unlike point estimates, which offer a single value as an estimate, confidence intervals account for the inherent variability in sampling and providing a measure of uncertainty associated with the estimate. So we've got a diagram here. We've got a bell curve with a confidence interval in it. And this particular confidence interval is a 95% confidence level. So that means the bulk of the bell curve is 95%, but 2.5% on the right hand and the left hand side is not part of the confidence interval. A confidence interval is a range of values derived from sample data that is likely to contain the true population parameter with a specified level of confidence. The confidence level represents the probability that the confidence interval will contain the true parameter in repeated samples. Common confidence intervals are 90%, 95%, and 99%. For example, a confidence interval for the population mean, mu, suggests that if we were to take many random samples from the population and calculate the confidence interval for each sample, approximately 95% of these intervals would contain the true population mean. So you've got three parts of the confidence interval, being the confidence level, the statistic, and the margin of error. The calculation of confidence intervals depends on the type of parameter being estimated and the distribution of the sample statistic. Here are the steps to calculate a confidence interval for the population mean, mu, when the sample size is large, n is greater than 30, or the population standard deviation, sigma, is known. So you calculate for the point estimate, you calculate the sample mean, x bar, as the point estimate of the population mean. So x bar is close to mu hat. And then s squared, that's your standard deviation squared, is close to sigma hat squared. And then we calculate your standard error. Your standard error is also called a standard deviation. Calculate the standard error of the sample mean. The standard error is the standard deviation of the sampling distribution of the sample mean and is given by standard error equals standard deviation divided by the square root of n. Then we have the critical value. Determine the critical value z squared corresponding to, z star, corresponding to the desired confidence level. The critical value is obtained from the standard normal distribution, z distribution, and represents the number of standard errors that correspond to the specified confidence level. So your critical value equals the margin of error divided by the standard deviation of the statistic. So then you've got your margin of error. Calculate the margin of error using the formula. Margin of error equals z times O squared, it looks like, divided by square root of n. And then you've got your confidence interval. Construct the confidence interval by adding and subtracting the margin of error from the sample mean. So your confidence interval equals x bar plus or minus z times sigma divided by the square root of n. For small sample sizes, n is less than 30, or when the population standard deviation is unknown, the t distribution is used instead of the z distribution, and the sample standard deviation s is used in place of the population standard deviation sigma. So your z distribution is really your bell curve. It's your normal distribution. And the t distribution is similar to the z distribution, but I think it has heavier tails. So we talk about the interpretation of confidence intervals. Interpreting confidence intervals requires understanding the confidence level and the range of values provided by the interval. A confidence interval provides a range of plausible values for the unknown population parameter, taking into account the variability in sampling. So, for example, suppose we have a 95% confidence interval for the population mean as 45.2 and 54.8. This interval suggests that we are 95% confident that the true population mean lies between 45.2 and 54.8. It is important to note that this interpretation does not imply that there is a 95% probability that the true mean lies within the specified interval. Instead, it means that if we were to take many random samples and calculate confidence intervals for each, approximately 95% of those intervals would contain the true mean. So, the importance of confidence intervals. Confidence intervals are important for several reasons, such as 1, it quantifies uncertainty, it makes references, helps in decision making, and it's a good comparator of estimates. So that concludes this video, and in the next video what we're going to do is we're going to actually go through some practice questions for confidence intervals in Python. So I hope you'll watch that video.